Welcome in .core. NASA is making stride toward a concept once deemed impossible, faster than light travel. Recent breakthroughs in space-time research suggest that manipulating space itself through a warp drive could bypass the speed limit set by Einstein's theory of relativity. In this video, we'll explore NASA's progress, the challenges ahead, and how these advancements could transform space exploration, even though a fully functional warp drive is still far off. Let's dive in. The discovery and theory, the concept of faster-than-light travel isn't about breaking the speed of light, but rather about moving space itself. This idea is rooted in the theory of space-time manipulation, which suggests that if space itself can be bent, it's possible to travel faster than light without violating the laws of physics. The foundation for this concept comes from a 1994 proposal by physicist Miguel Alcubierre, who introduced the Alcubierre drive. Alcubierre's model suggested that instead of a spacecraft moving faster than light, space-time around the ship would be manipulated. The spacecraft would stay within a warp bubble with space stretching behind it and compressing in front, allowing the spacecraft to effectively surf through space faster than light can travel in the surrounding space-time. In essence, the ship would remain sublight, but the space around it would move, allowing it to travel faster than light. However, creating this warp bubble requires a substance called negative energy, a form of exotic matter that is required to bend space-time necessarily. Negative energy, however, is not something that has been found in significant quantities in nature or created in laboratories. This is the key challenge. NASA's involvement with warp drive research dates back to the 2010s when Dr. Harold Sonny White and his team at the Johnson Space Center began investigating the theoretical principles behind Alcubierre's model. Their focus wasn't to create a working warp drive, but to explore the feasibility of the underlying physics. NASA's recent developments in 2021, NASA made significant progress by using a technique called worldline numeric, which allowed them to model space-time geometries in much greater detail. With this method, Dr. White's team demonstrated that a specific type of structure called a casemate cavity could theoretically resemble the conditions needed to create a warp bubble. While this wasn't an actual warp bubble, it gave researchers a roadmap for testing the idea in practical terms. The casemate effect is a quantum phenomenon where two objects placed extremely close together in a vacuum create a force due to the energy fluctuations in space. This tiny effect, when studied on a nanoscale, showed promise of resembling the energy conditions required for a warp bubble. NASA's work in this area provided a crucial experimental foundation, proving that these structures could be used to test and refine the theoretical models that underlie the concept of a warp drive. In addition to modeling space-time geometries, NASA's research involved using interferometers, sensitive instruments designed to detect distortions in space-time. The White-Jude warp field interferometer developed in the 2010s was one such tool. It was designed to detect any subtle shifts or distortions in space-time around energized devices. While it did not detect a warp field, the experiment helped map the noise sources, giving scientists valuable data on how to refine future experiments. These efforts are part of NASA's broader goal of improving the tools and techniques needed to measure space-time distortions, and they are laying the groundwork for future experiments that could one day test whether warp drive technology is truly possible. Challenges and future outlook. Despite the progress made, the road to achieving a functional warp drive is filled with challenges. The most significant of these is the energy requirement. According to the theoretical models, creating a warp bubble would require massive amounts of negative energy, something that current physics cannot provide in large quantities. Negative energy, while a fascinating concept, remains elusive, and its creation would likely require discoveries in physics that we are far from making. Even if negative energy could be produced, there's another fundamental obstacle. The energy densities required to create and sustain a warp bubble are enormous. This makes the creation of a working warp drive seem like an impossible task with current technology. For now, this remains a theoretical challenge, and many scientists are exploring alternative approaches to manipulate space-time without violating known laws of physics. One promising area of research involves positive energy warp analogs. These are approaches that aim to manipulate space-time using regular positive energy, which would avoid the need for exotic matter like negative energy. While these methods wouldn't allow for faster-than-light travel, they could still offer practical applications in space travel, such as improving spacecraft efficiency, station keeping, or even deep space exploration. These positive energy models could provide a pathway for future advancements, even if they don't break the speed limit of light. Researchers are also exploring subliminal warp geometries to improve propulsion systems, enabling faster travel within our solar system. While not faster than light, these methods could enhance efficiency for space exploration. Current research is focused on improving interferometers to detect tiny quantum effects in space-time and developing nanoscale geometries to test predictions. These advancements aim to better understand space-time and explore potential applications even as a full warp drive remains distant. NASA's warp drive research is making exciting progress, laying the groundwork for future space exploration. While faster-than-light travel is still far off, each breakthrough brings us closer to understanding how space-time could one day be manipulated for travel. If you enjoyed this deep dive into this topic, make sure to like, subscribe, and comment below with your thoughts. Do you think warp drives will ever become a reality, or is it just a dream for the far future? Let us know. Thanks for watching. Cool.